Hi and welcome to Maths class. Today we're going to look at one worked example where we're going to solve a problem involving the normal distribution by using transformations to the standard normal curve. Okay, so we're going to make z values out of the values given in the question. So I've got a few examples of this that we're going to look at in the video that follows this. But those are worded questions where we have to sort of pull all the information out of the words. We're going to start for now with a really straightforward practical question where we're given the information here. So x is normally distributed with a mean of 52.3, and we know that the probability that x is less than 48 is 0.229. And I need to calculate the standard deviation to 2 decimal places. So this is different from previous questions where we would be given the mean and the standard deviation and need to calculate probability, or when we were given the probability and we were told it was a standard normal curve and we just needed then to calculate the value, the z value. So this is different. This time it's not a z value, it's an x value, and the thing we're looking for is standard deviation. So let's get started, and I just want to point out that what we're going to use is this transformation equation over here. We're going to change our x values into z values. So we know that x is normally distributed. We know that the mean is 52.3, and we don't know the variance or the standard deviation. But we also know that the probability that x is less than 48 equals 0.229. What I'm going to do now is change this into this. So instead of x, I'm going to say the probability that z is less than, and instead of 48, it's going to be 48, that's my x value, minus the mean, mu, 52.3, over the standard deviation. Well, this I don't know. I don't know the standard deviation. Still equals 0.229. But the reason that this is different is now this is a z value. This standard deviation is the standard deviation of x, not of z. Z has a standard deviation of 1. So now I can use my calculator to work out what this value is. It's very similar to the last examples we were doing, except that now instead of just a value of c here or k, I've got a little equation. So first of all, let's work out 48 minus 52.3, that's negative 4.3 over sigma is going to be, I'm going to grab my CAS. So let's do that. Turn on CAS. There it is. So interactive, I'm still on distribution. It's going to be inverse because I know the probability. So when I know the probability, I'm always looking at inverse. And it's a left tail because its z is less than. And I'm going to keep this because this is now a z value. So it's a standard curve, which means sigma is 1 and mu is 0. And the probability is 0.229. Put that in. All right, I get negative 0.7421. Now, I am going to write that in. What was it? 0.7421. Hang on. Negative 0.7421. I am going to write it in, but when I do my final calculation, I'm not going to use this rounded value. I'm going to keep the value that's in my CAS. So that means that sigma is going to equal negative 4.3 over negative 0.7421. Remembering this is the sigma, which is the standard deviation of my original x. So I just put that into my calculator, negative 4.3 divided by the answer that I already have. So I'm going to go negative 4.3, whoops, I can type, negative 4.3 divided by the answer. So I'm just going to my keyboard. You can't see it, but I'm going keyboard and pressing answer. So that's, instead of copying that down, I just say use the answer I just found, and I get 5.051. How many decimal places do I need? 2. So that's 5.05. Oh no, I've done something wrong here. Why is that there? Get rid of that. Try again. There, that's better. Negative 4.3 divided by the answer is 5.79 to 2 decimal places. So I'm just going to write that down. Oops, approximately equals 5.79. Just underline it so everyone knows that's the answer. Okay, so that's all I do. I need to change x into a z value by using this equation here. And when I do that, I can now use my calculator to find out what this boundary value is going to be. But this boundary value is not an unknown, it's a little equation, negative 4.3 over sigma. So I write those down and then I just solve this. Okay, that's all there is for this first video on this work.